Are you ready to master the frontier of technology where artificial intelligence meets the edge? As industries shift from cloud-centric to edge-native intelligence, the AI Edge and IoT Systems certification is your golden ticket to the future of engineering. In this video, we will cover AI Edge and IoT AI Systems certification practice exam questions and explanations. Prepare for your AI Edge and IoT AI Systems certification with this comprehensive practice test. In this video, we dive deep into 30 high-yield practice questions designed to mimic the actual AI Edge and IoT AI Systems exam. We cover everything from hardware acceleration and model optimization to low-latency deployment and sensor fusion. Before we jump into the first question, make sure to hit that subscribe button and turn on notifications so you don't miss our deep dive Tech Certification Series. What is the primary motivation for performing AI inference at the edge rather than in a centralized cloud environment? Option A. Increased storage capacity for large datasets. Option B. Reduction in latency and bandwidth consumption. Option C. Ability to use high power consumption GPUs. Option D. Simplified model training workflows. The correct answer is B. Edge computing brings computation closer to the data source. By processing data locally on the device or a local gateway, you eliminate the need to transmit massive amounts of raw data to the cloud. This significantly reduces latency, critical for real-time applications like autonomous driving, and saves significant network bandwidth costs. While cloud offers more storage and power, the edge is specifically utilized for responsiveness and efficiency. Which technique involves reducing the precision of the weights and activations of a neural network from 32-bit floating point to 8-bit integers? Option A. Pruning. Option B. Knowledge distillation. Option C. Quantization. Option D. Weight sharing. The correct answer is C. Quantization is the process of mapping continuous infinite values to a smaller set of discrete, finite values. In AI, this usually means converting FP32 weights to int8. This reduces the model size by 4x and allows the model to run on hardware that supports integer arithmetic acceleration, like many mobile CPUs and NPUs, leading to faster inference with a minimal trade-off in accuracy. Which hardware component is specifically designed to accelerate tensor operations using low power? Application-specific integrated circuits, ASICs. Option A. General-purpose CPU. Option B. Google Edge TPU. Option C. Standard SATA SSD. Option D. High bandwidth router. The correct answer is B. The Google Edge TPU, Tensor Processing Unit, is a purpose-built ASIC designed to run AI at the edge. Unlike CPUs, which are general purpose, the TPU is optimized for the specific mathematical operations required for deep learning, mostly matrix vector multiplications. It provides high performance per watt, making it ideal for IoT devices that have strict power constraints. In the context of model compression, how does pruning differ from quantization? Option A. Pruning reduces the number of parameters, while quantization reduces the bit depth of parameters. Option B. Pruning increases model accuracy, while quantization decreases it. Option C. Pruning is only for training, while quantization is only for inference. Option D. There is no difference. They are synonymous. The correct answer is A. Pruning involves identifying and removing redundant or non-critical neurons or connections. Weights from a neural network, effectively making the model sparser. This reduces the total count of parameters. Quantization, on the other hand, keeps the number of parameters the same but represents them using fewer bits, e.g., 8 bits instead of 32 bits. Both aim to reduce model size and speed up inference. Which communication protocol is most suitable for IoT devices that require low power consumption and transmit small packets of data over long distances? Option A, Wi-Fi 6. Option B, LoRaWAN. Option C, Gigabit Ethernet. Option D, USB 3.0. The correct answer is B. LoRaWAN, Long-Range Wide Area Network, is designed specifically for low power, wide area (LPWA) networking. It allows IoT sensors to communicate over several kilometers while consuming very little battery power. Wi-Fi and Ethernet provide much higher throughput but are not suitable for long-range, battery-operated remote sensors. Which toolkit is developed by Intel to optimize and deploy AI inference across various hardware, including CPUs, integrated GPUs, and VPUs? Option A, TensorRT. Option B, CoreML. Option C, OpenVINO. Option D, PyTorch Mobile. The correct answer is C. OpenVINO, Open Visual Inference and Neural Network Optimization, is Intel's cross-platform toolkit. It allows developers to optimize models from frameworks like TensorFlow or PyTorch and deploy them efficiently on Intel hardware. It includes a model optimizer and an inference engine that abstracts the underlying hardware complexity. What is federated learning, and how does it benefit IoT AI systems? Option A, centralizing all user data to a single server for maximum training speed. Option B, training models locally on devices and only sharing updated weights with a central server. Option C, encrypting the hardware chip to prevent physical tampering. Option D, a method to increase the resolution of edge camera feeds. The correct answer is B. Federated learning is a decentralized machine learning technique. Instead of sending sensitive raw data from IoT devices to the cloud, the training happens on the device itself. Only the learned weights or gradients are sent to a central server to improve a global model. This enhances privacy and reduces the need for massive data transfers. Which metric is most critical for an AI system running on an autonomous drone for obstacle avoidance? Option A, training time. Option B, model interpretability. Option C, inference latency. Option D, data center uptime. The correct answer is C. Inference latency refers to the time it takes for a model to process an input and produce an output. For an autonomous drone, the system must detect obstacles in milliseconds to avoid a crash. While accuracy is important, high latency would make the drone react too late, regardless of how accurate the model is. In knowledge distillation, what are the roles of the teacher and student models? Option A, the student trains the teacher to be more accurate. Option B, the teacher is a small model, and the student is a large model. Option C, the student, small model, learns to mimic the output behavior of the teacher. Large, complex model, Option D. They are two identical models training on different datasets. The correct answer is C. Knowledge distillation is a compression technique where a small, efficient student model is trained to reproduce the results of a large, pre-trained teacher model. The goal is to transfer the complex knowledge of the teacher into a lighter student model that can run efficiently on edge hardware while maintaining near-teacher performance. What is a fog computing layer in an IoT architecture? Option A. A layer of clouds that obscures satellite data. Option B. An intermediary layer between edge devices and the cloud, typically located at a local gateway. Option C. A specialized type of GPU memory. Option D. The process of deleting old data to make room for new data. The correct answer is B. Fog computing extends cloud computing to the edge of an enterprise's network. It acts as a middle tier between the IoT sensors, edge, and the remote data center. Cloud, fog nodes, like local servers or smart gateways, can aggregate data and perform heavier processing than an individual edge device, but with lower latency than the cloud. Which framework is specifically designed by NVIDIA to maximize inference performance on Jetson and RTX platforms? Option A. TensorFlow Lite. Option B. TensorRT. Option C. Onyx Runtime. Option D. Keras. The correct answer is B. NVIDIA TensorRT is a high-performance deep learning inference optimizer in runtime. It takes a trained model and optimizes it for NVIDIA GPUs by performing layer fusion, precision calibration, INT8, FP16, and kernel auto-tuning. It is the industry standard for deploying AI on NVIDIA edge hardware. What does NPU stand for in the context of mobile and edge AI hardware? Option A. Network Processing Unit. Option B. Neural Processing Unit. Option C. Node Power Utility. Option D. Non-parallel unit. The correct answer is B. An NPU, Neural Processing Unit, is a specialized circuit that implements all the necessary control and arithmetic logic needed to execute machine learning algorithms, usually by operating on predictive models like artificial neural networks. NPUs are common in modern smartphones to handle tasks like face recognition and image enhancement. Why is data augmentation particularly useful when developing models for IoT applications like industrial visual inspection? Option A. It reduces the size of the model for deployment. Option B. It artificially increases the diversity of the training set to improve model robustness. Option C. It speeds up the inference time on the edge device. Option D. It encrypts the data before it is sent to the cloud. The correct answer is B. In many IoT scenarios, it is difficult to collect thousands of images of faulty parts. Data augmentation, rotating, flipping, or changing brightness of existing images allows developers to create a larger, more robust dataset. This helps the model generalize better to different lighting or angles it might encounter in a real factory environment. Which of the following is a significant security risk for AI models deployed on physical edge devices in public spaces? Option A. Model inversion, extraction attacks. Option B. Inability to update the firmware. Option C. Lack of internet connectivity. Option D. The model being too small to be secure. The correct answer is A. When a model is stored on a physical device, like a smart camera in a park, an attacker with physical access can potentially extract the model's weights. Through model inversion or extraction attacks, they could potentially reverse engineer sensitive training data or steal intellectual property. This is why hardware-level encryption and secure boots are critical. What does the TOPS metric represent when evaluating edge AI hardware? Option A. Total operations per second. Option B. Tera operations per second. Option C. Technical output power system. Option D. Timed output process schedule. The correct answer is B. TOPS stands for tera operations per second. It is a common benchmark used to describe the raw computing power of AI accelerators, like NPUs or TPUs. While not the only factor in performance, it gives a baseline of how many trillions of operations the hardware can handle every second. TensorFlow Lite uses which file format for its optimized models? Option A. PB, protobuf. Option B. H5, HDF5. Option C. TFlight. Option D. Onyx. The correct answer is C. TensorFlow Lite converts standard TensorFlow models, often PB or saved underscore model format, into a special TFlight flatbuffer format. This format is designed to be efficient for storage and fast to load, execute on mobile and embedded devices. In an IoT AI system, what is sensor fusion? Option A. Combining data from multiple sensors to achieve more accurate and reliable information. Option B. The process of physical sensors melting due to high heat. Option C. Replacing all sensors with a single high-definition camera. Option D. A method of backing up data to multiple cloud providers. The correct answer is A. Sensor fusion is the process of combining sensory data derived from disparate sources such that the resulting information has less uncertainty than would be possible when these sources were used individually. For example, an autonomous robot might fuse lidar, camera, and IMU data to understand its position more accurately than if it used only one of those sensors. A container, like Docker, is often used in edge AI deployment because it Option A. Reduces the size of the AI model file. Option B. Ensures the application runs consistently across different edge hardware environments. Option C. Eliminates the need for a GPU. Option D. Increases the physical durability of the IoT device. The correct answer is B. Containers package the AI application, its dependencies, and libraries into a single unit. This portability is crucial for edge AI because it ensures that a model developed on a Linux workstation will run exactly the same way on an industrial edge gateway or a remote server, solving the "it works on my machine" problem. Which of the following is a common challenge for on-device training compared to cloud training? Option A. Excessive bandwidth availability. Option B. Limited thermal and power budgets. Option C. Too much labeled data. Option D. Extremely high RAM availability. The correct answer is B. Edge devices are often battery-powered or have limited cooling. No fans. Training is a computationally expensive process that generates significant heat and consumes a lot of power. Managing these thermal and power budgets is a major challenge when trying to implement learning capabilities directly on a small IoT device. How does batch size typically affect inference on an edge device compared to a cloud server? Option A. Edge devices always prefer large batch sizes, e.g., 128. Option B. Edge devices usually optimize for batch size equals 1 to minimize latency. Option C. Batch size has no effect on edge devices. Option D. Edge devices cannot process batches larger than 2. The correct answer is B. In the cloud, we often use large batch sizes to maximize throughput, processing many images at once. However, at the edge, we are usually processing a single stream of data, like a single camera feed, in real time. Therefore, we optimize for a batch size of 1 to ensure the lowest possible latency for that specific piece of data. What is the primary role of the ONNX Open Neural Network Exchange format? Option A. To provide a way to encrypt AI models. Option B. To allow model interoperability between different frameworks like PyTorch, TensorFlow, and MXNet. Option C. To replace the need for Python in AI development. Option D. To automatically label images for IoT datasets. The correct answer is B. ONNX provides an open-source format for AI models. It defines a common set of operators and a common file format to enable AI developers to use models with a variety of frameworks, tools, runtimes, and compilers. You can train in PyTorch, export to ONNX, and run it on a framework-agnostic runtime like ONNX Runtime. FPGA, Field Programmable Gate Array, is often used in Edge AI because Option A. It is the cheapest possible hardware option. Option B. It allows for hardware-level customization and can be reconfigured for specific AI tasks. Option C. It is exactly the same as a standard CPU. Option D. It only supports training, not inference. The correct answer is B. FPGAs are integrated circuits designed to be configured by a customer after manufacturing. This allows developers to create custom hardware logic for specific AI workloads, offering a balance between the high performance of an ASIC and the flexibility of a CPU, GPU. What is the primary disadvantage of using satellite connectivity for IoT AI systems? Option A. Extremely low cost. Option B. Very high latency. Option C. Short range. Option D. Low power usage. The correct answer is B. While satellites provide global coverage, the time it takes for a signal to travel to space and back results in very high latency. This makes it unsuitable for real-time AI feedback loops, though it is useful for intermittent data reporting from extremely remote areas. What is post-training quantization, PTQ, in the context of TensorFlow Lite? Option A. Quantizing the model while it is still training. Option B. Quantizing a model after training is complete without needing to retrain. Option C. A method to increase the number of layers in a model. Option D. The process of adding more data to the model after it is deployed. The correct answer is B. Post-training quantization is a conversion technique that reduces model size while also improving CPU and hardware accelerator latency, with little degradation in model accuracy. It is performed on an already trained float model, making it much simpler than quantization-aware training. COT. Which architecture is better suited for a smart city traffic management system that needs to coordinate hundreds of cameras? Option A. Pure cloud. All processing in a remote DC. Option B. Pure edge. Each camera acts independently with no communication. Option C. Edge fog cloud. Tiered processing and coordination. Option D. Manual observation by humans only. The correct answer is C. A tiered approach is best. Individual cameras, edge, can detect cars, local gateways, fog, can coordinate traffic light timings based on several cameras, and the cloud can analyze long-term traffic trends for city planning. This balances latency, bandwidth, and global visibility. What does power efficiency, performance per watt, measure in Edge AI? Option A. How fast the device can charge its battery. Option B. How many AI operations can be performed for every joule of energy consumed. Option C. The total electricity bill of the data center. Option D. The brightness of the device's status LEDs. The correct answer is B. For IoT and edge devices, raw speed isn't everything. Battery life and heat management are paramount. Performance per watt tells you how efficient the processor is. A device that is fast but drains the battery in 10 minutes is useless for most remote IoT applications. What is adversarial machine learning in the context of Edge AI? Option A. Two AI models competing in a game. Option B. Maliciously designed inputs meant to trick an AI model into making a wrong prediction. Option C. A new type of high-speed Wi-Fi. Option D. Training a model to be angry at users. The correct answer is B. Adversarial attacks involve subtly altering an input, like adding invisible noise to an image, that causes an AI model to misclassify it. In an edge context, this could mean tricking a smart lock's facial recognition or a self-driving car's sign detection. Protecting against this is vital for edge security. In the OpenVINO toolkit, what is the inference engine? Option A. A tool used to scrape images from the web. Option B. A runtime library that executes the optimized model on the target hardware. Option C. The hardware chip itself. Option D. A programming language similar to C++. The correct answer is B. The OpenVINO inference engine is a set of C++ libraries with Python bindings that provide a common API to deliver inference solutions on the platform of your choice. CPU, GPU, VPU, FPGA. It manages the loading of the model and its execution on the specific hardware plugin. Which of these is a benefit of model compression for IoT devices? Option A. Slower inference times. Option B. Larger memory footprint. Option C. Reduced energy consumption. Option D. Requirement for more expensive hardware. The correct answer is C. Compressed models, via pruning or quantization, require fewer computations and fewer memory accesses. since moving data from memory to the processor is one of the most energy-intensive tasks. A smaller, more efficient model directly results in reduced energy consumption and longer battery life. What is the cold start problem in the context of serverless functions at the edge? Option A. The device physically being too cold to turn on. Option B. The delay experienced when a function is triggered for the first time or after a period of inactivity. Option C. The model failing to converge during training. Option D. Running out of storage space on the edge node. The correct answer is B. Serverless edge functions often spin down to save resources when not in use. When a new request comes in, the system must spin up the container or environment, which causes a delay known as a cold start. In AI applications, this can be problematic if the model is large and takes several seconds to load into memory. That wraps up our 30-question practice run for the AI Edge and IoT Systems certification. How many did you get right? Let us know your score in the comments. If you found this helpful, give us a thumbs up and share this video with your fellow engineers. For a deep dive into each of these topics, make sure to check out the full course link below. For the full-length practice exams and detailed study guides, check the link in the description below.